Hey guys, it's Leia. Today we're going to learn about how to solve integrals using substitution. Last video we learned how to solve integrals with trig functions by reducing the trig functions into sine of x or cosine of x. But what happens when we have the integral of sine of x and cosine of x with respect to x? They're reduced to their simplest form, sine of x and cosine of x, and we don't know what to do next. Well, this is when we use substitution. Substitution is when you set an inner function g of x equal to u and its derivative g prime of x dx equal to du. You then substitute u and du back into the integrand to get a simpler function to solve. Substitution is complicated at first, but the best way to get the hang of it is to keep practicing and trying different problems. A tip for when knowing when to use substitution is, when in doubt, try it out. Substitution works for many integrals, so there's a good chance by trying it will work. Another tip is, if there is a function present and it has an inner function g of x, see if you can take its derivative. If not, then try substitution. We'll go back to the problem I was talking about before and solve it. We have the integral of sine of x times cosine of x with respect to x. In this case, we can set either sine of x or cosine of x equal to f of g of x. So we'll set sine of x equal to f of g of x and g prime of x equal to cosine of x dx. So we'll set u equal to sine of x and du equal to cosine of x dx. And we'll substitute u and du back into the integrand, and now we can see we have a much simpler function we can solve. We'll use the power rule and get 1/2 u squared plus c. Now we'll substitute sine of x back into u, and we'll get 1/2 sine squared x plus c, which is our final solution. Next example, we have the integral of x times e to the x squared with respect to x. We'll set x squared equal to g of x, our inner function, and x d of x equal to g prime of x. So we set u equal to x squared, and we'll take the derivative, and du is equal to 2x dx. But we can see that there's no 2x dx in the integrand. So we divide by 2, and we get 1/2 du equals x dx. And now we can see that x dx is in the integrand. So we'll substitute u and 1/2 du into the integrand, and we'll get the integral of e to the u times 1/2 du, which is much easier to solve. We'll use the constant multiplication rule and we'll pull out the 1/2. Now we'll use the exponential rule, and we'll get 1/2 times the sum of e to the u plus c, and this simplifies to 1/2 e to the u plus c. We'll substitute x squared back in for u, and we'll get 1/2 e to the x squared plus c, our solution. Last example, we have the integral of x over x squared plus 1 with respect to x. Let's rewrite this to the integral of 1 over x squared plus 1 times x with respect to x. Here we'll peg u to equal x squared plus 1 and du equal to 2x dx. We see that there's no 2x dx, so we'll divide by 2, and we'll get 1/2 du equals x dx. So we'll substitute u and 1/2 du into the integrand, and we'll get the integral of 1 over u times 1/2 du. We'll use the constant multiplication rule and we'll pull out the 1/2. Now we'll use the natural log identity of the integral of 1 over x with respect to x equals to ln of x. We get 1/2 times the sum of ln of u plus c. We simplify and substitute x squared plus 1 back in for u and get 1/2 times ln of x squared plus 1 plus c, and that is our answer. As I said before, the only way to get good at solving integrals with U substitution is to keep on practicing. So for more help, visit www.symbolab.com and click on the Practice tab.